think that's all set up. Okay, let's do that, and then let's go ahead and share the screen as well. We can just share the desktop. And I need a couple of things actually. I need the users and I need my chat. But actually, I'm not going to worry about the users for right this second. I'll scan that a little bit later. Okay. Oh, and then I also like to have this in the background. Let's do this one. I think this is about right. Let's move this down here. You can join them. Let's just go like this. Okay, that's fine. All right. I'm going to try the attendance one more time. Let me hide. Oh, we need to open that up too. That's fine. Let's close this out. Close. We can just do a new one, I guess. Thank you. Let's go to Pearson. Okay. Let me think. Yeah, I wanted to try attendance one more time. I guess we can just do this then for right now. It's trying to load. It's just moving really slow. Okay, I'm gonna give up. Oh, wait. Okay. Let's go to courses. Come on. This is the actual lab session. I don't like how long that's taking to load. But I know if I don't do it now, I'm gonna forget. All right, so I'm gonna abandon that for now. It's just taking way longer than I wanted to. Let me check and make sure that we're still streaming. That looks proper. Okay. So a few announcements. So yeah, as far as Pearson is concerned, so yeah, I spoke with, I asked around like a few of my colleagues and my supervisor and people like that. This message is correct that like the Pearson is no longer included in our tuition, so we do have to purchase access. So I have had at least one student. I had several students get full access, but I know I have at least one student that got full access. He bought the book new out of the bookstore, and it came with a MyMathLab access code. So you can buy the book new out of the bookstore. Again, just make sure that it comes with the MyMathLab access code. Otherwise, you can actually just purchase it directly from MyMathLab. Yeah, I'm still trying to get into the attendance. But you can purchase access, full access directly from MyMathLab. Okay? So that was the conclusion. Go ahead. Was there a question?
No, I was just saying I had just bought the math lab thing before class because I think my junk it ends today.
Yeah, it's fine. So yeah, it's fine as long as you just kind of give yourself full access. That's the simple thing. All your grades will be there. You can see all your work. You can access all your files. Okay. All right.
Yeah.
Go ahead.
Quick, Professor. Hey, can you send us an official Zoom one again, because Blackboard be acting up sometimes and on my side.
I think you guys can actually invite people. It's the same scan code.
Yeah.
That code, like if you just screenshot it and save it in your photos or whatever, you can scan that same code each time.
Right. Shout out to Mike. He sent it to me though. Appreciate it, bro.
Yeah. So once you have it, that one, because I finally figured out what I needed to do for it to work properly. So once you have that QR code, just save it somewhere and you can access every time. Okay, attendance is trying to pop up. All right. As much as I don't want to stream you guys' names. All right, so we get out of what? We go from three. We go from is it 350 to 505? So about 450, we'll try attendance again. Okay, we'll try to stop the stream. So just remind me at 450. Let me see. Hey Siri, set an alarm for 4:50 p.m.
Setting.
Okay.
Okay. I set an alarm for 4:50 p.m.
So I think that when we last left off, we still had like a few more slides left to do, right? I think we were doing about 15 slides every time we met on section 1.3. So we're going to go ahead and finish out 1.3 today. Did anybody want to ask? Yeah, there's no worries. Blackboard is acting up for me too, so that's just how it goes. Again, best thing is you just got always have a backup and kind of be ready to go. Does anybody else have any questions before we get started? But I can at least, let me see if I do. Let me stop sharing the screen. I think that'll show the way I want it to. I can hide that for now. I can get rid of that too. I'm gonna screenshot this. This is at least what I have for right now, and I'll just use that later. I'm gonna share my screen. I can do the whole desktop. That's fine. I'll keep that. Is that right? Man, everything is moving slow today. It was moving so smooth earlier, and now it's just like I got all excited, and now it's just like no. Okay. All right, I'm gonna just go with it and close this out. We'll hit done. Let me see. I think I'm low on space too. I tried to delete some stuff. I don't want to record the session. It's not recording. Come on. Okay. All right. So I can't think of anything else. So I'm going to go ahead and show this. Is that moving slow too? There we go. And then let me do this, and then we'll be ready. Okay. All right. So I will be monitoring the chat. You should be able to see the chat. And I'll be monitoring the chat as we kind of go through the presentation. We'll go solid for about 40 minutes or so when that timer goes off, and then we'll try to take attendance again then. So, I took a screenshot of who was here, at least on time. But yeah, we'll kind of work it that way. And if there aren't any burning questions, if you've emailed me and I haven't responded, like at the end of class is a good time to clear up that item. So if you email me about something at the end of class today is a good time to we can just talk about it in person. Because I'm totally behind on my emails. I don't know if I'm gonna be able to get caught up with that or not. I can try, but let me try closing this out because I know that helps this. I'm gonna close that out too. And this is this one, right? This is the one that we want to be working on. Okay, looks good. All right. So we're going to pick up where we left off. One of the last things that we talked about on this past Tuesday, we did an example on finding the range of a function, right? So we have about 15 slides remaining, give or take a few, and we're going to just finish out this section 1.3. So we have this thing called the vertical line test. So I think last time we said that if we have repeating x's, then it's just like in life. If we like constantly going back to our x's, it could be a little bit dysfunctional. That's a PJ, but that's essentially That's essentially what's going on here. So if we have repeating x's, then we say that it's not a function. And so in a graphical sense, if a graph fails the vertical line test, in other words, if we can draw a vertical line and it touches the graph more than once, then we say that graph is not a function. Okay, we say that it's not a function. All right, I'm gonna let that be. All right. Can anyone tell me if this is a function, yay or nay? Can we draw a vertical line and it touches it more than once? Is this a function, yes or no?
Wait, no.
No? Let's see.
Touch it more than one time.
So let's see. It touches it once there, once, and we have twice there, right? So those 2 points.
Oh, okay.
So we would say that this is not a function. Okay. So this one will be a no, right? Not a function. It has not passed the vertical line test. Is this a function? Yes or no? No, right? It fails the vertical line test as well.
Sir.
Is this a function?
Yes.
Yeah,
Yes.
this passes, right? We can draw, no matter where we draw a vertical line, it touches it once. So this is a function. Same for this one. No matter where we place a vertical line, it only touches it once. Okay. So no matter where we place the vertical line, it touches it once. Okay. I'm going to get rid of that. So this one's a function as well. All right. So let f of x be this. Is this point on the graph? Find all the values of x. Hang on. I don't know if that's me or not. I'm going to go here, and I think it's like this. Yes. Okay. Let's see. Is the point 1, 3, 1, negative 3 on this graph? So let f of x be this. Find all the values of x such that x, 5 is on the graph. Did I make pages for these? No. Okay, so let me get a copy of this and let's work through this one. I don't need that one. All right, let's copy this. Let's copy. And let's add a page. Okay, and then let's change the view. And let's introduce some graphic. Okay, so we have this example. So we say let f of x be this. Is this point on the graph, right? Okay. So then for part A, we have f of x equals x squared minus 2x minus 3, right? So then ax, verify that the point 1, negative 3 is on the graph, right? So what this means, if we do f of 1, we should get negative 3. Let's see what happens. So we're going to replace each x with a blank set of parentheses, right? And then into the blank parentheses, we're going to do the 1 in question. Okay? So then if we keep going, that's going to be a 1. That's going to be negative 2. That's going to be negative 3. I think ultimately we get negative 4, which is not negative 3, right? So then that would be a no. Okay. Let's go on to B. So if we have a question, just unmute yourself or type in the chat. I prefer typing in the chat, but it's okay if you unmute yourself to ask the question. And I'm monitoring the chat, and I'll come up and I'll check it periodically. Find all x values such that x, 5 is on the graph. So in other words, this one is saying let y equal 5, right? So we're going to take our function, which is this x squared minus 2x minus 3. That's not equal to 0. Equal to 5 in this case. And then we're going to solve for x. Okay? So I'm going to set it equal to 0. Let's kind of go like this really quickly. Oh no, I hit something. There we go. I'm gonna line up my equal signs. So if we set it equal to 0, we're gonna have x squared minus 2x minus 3 minus 5 equals 0. So then that gives us, what is that, minus 8 equals 0. Okay, so then we want to do this technique. Can somebody tell me what is this called that I'm doing here? What is this technique called?
Factoring.
Factoring, right? We got a trinomial. We set it equal to 0. Anybody feel confident in walking me through this? So what are we looking for when we factor this?
Find two numbers that multiply to give you -8, but add up to give you -2.
Okay. Can you give me those two numbers?
-2, or -4 and 2.
-4 and 2, okay. Because notice, -4 times 2 is -8, and -4 plus 2 is -2. Okay. So then at this stage, we're invoking a technique called the zero factor property. When we have two or more things that multiply to give us 0, then basically we just set each thing to 0 and solve, right? We're going to have this x plus 2 equals 0, or x minus 4 equals 0. So then we get x equals -2, or x equals 4. Let's go back to the context of the original. I'll find all values of x. So then we get x equals -2 and 4. Okay, let's check this. What should be the case, if we plug these into the original, oh, come on. If we plug these into the original, they should both give us 5, right? So let's check it out. Maybe jump the gun a little bit there. So this is the pertinent. This is what's pertinent to this, right? So what I'm going to do, I'm going to use my calculator, just as a demo. Calculator is here. All right. So the original, we got x squared minus 2x minus 3. So I'm going to go to my y equals. I'm going to type x squared minus 2x minus 3. I'm going to quit. I'm going to go to the left of the clear button is the variables. So it's like it's right here, variables, VARS. I'm going to go over to y variables. I'm going to click number 1, and I'm going to call the function I just typed in. And then when x is -2, again, the answer should be 5. And then when x is 4, the answer should be 5 as well. Okay, so they both gave us 5, the desired result. So we're good to go there. Okay. It says find all, basically the y-intercepts and the x-intercepts for part D. So I'm going to bring my graph paper back. So then part C asks us to find the y-intercepts. How do we find the y-intercept?
X equals 0.
Set x equal to 0. Okay. So the original, I think we had f of x equals x squared minus 2x. Nope, that's not it. Wait a minute. The original was -3, right? X squared minus 2x minus 3. Okay, so if we set x to 0, that means we're going to do f of 0. We're going to have 0 squared minus 2 times 0 minus 3. Notice this goes to 0, this goes to 0. This is our answer. Okay. So then the y-intercept is going to be 0, -3. And then the x-intercept, let me just go ahead and start on another page. So then part D, again, for the x-intercept, we're going to set y equal to 0. Okay? So then we have this x squared minus 2x minus 3 equals 0. We want to factor x and x, plus and minus. I think it's a negative 3 and a positive 1. So then if we set each one to 0 and solve, we get x equals negative 1 or x equals 3. And you can write it in the form negative 1 comma 0, 3 comma 0. Okay, let's see how do we do. Let's undo. Okay, so let me see if I go to style. Let's see something if I pull up my calculator again. I'll go to my y equals. Okay, so that is the original. So I want to test when x is negative 1. When x is negative 1, we should get 0. And when x is 3, we should get 0. Okay? And then when x is 0, we should get negative 3. Okay, so we confirmed all of our results. All right, so then let's kind of continue in the notes. Okay. Man, I be talking about this stuff all the live long day. My first class starts at 8. How I'm still like moving is beyond me. So the first one, let me see. So 1, negative 3 is not on the graph, so I think they got the same thing that we got. Part B. So I think negative 2 and 4. Did we get 2 answers for part B? Yeah, negative 2 and 4 is correct. Okay. I think we got the negative 3. And we got negative 1 and 3 for those. Okay. We're actually almost done with this section. Can I get a volunteer to read this slide for me?
I'll read it. Many drugs used to lower high blood cholesterol levels are called statins.
I think it's
and are
statins.
very popular. What is it?
I think it's statins.
Okay,
So
statins and are very popular and widely prescribed. Bioavailability is the amount of a drug you have ingested that makes it into your bloodstream.
Keep going.
A statin with a bioavailability of 30% has been prescribed for Boris. Boris is to take 20 milligrams, right, of this statin every day. During the same day, 1/2 of the statin is filtered out of the body. Find the maximum concentration of the statin in the bloodstream on each of the first 10 days using the drug and then graph the result.
Let me see. Statin with availability of this has been prescribed for Boris. Boris takes 20 milligrams of statin every day. During the same time, half the statin is filtered out of the body. So if we can make a function, right? Is the function linear? Find the maximum concentration of statin in the bloodstream on each of the first 10 days using the drug and graph the result. Let me see. So it says a bioavailability of 30% has been prescribed. Boris is to take 20 milligrams of the statin every day. During that same time, half of the statin is filtered out of the body. Let me see about this. During the same time, half the statin is filtered out of the body. So like in 24 hours, he's going to have, what, half of it remaining? So if he takes 20 on the first day, after 24 hours, 10 is going to be left over. But I'm not sure about what the 30% means. Let's kind of go forward. Okay, since the statin has a 30% bioavailability and Boris takes 20 milligrams per day, the maximum concentration in the bloodstream is going to be 30% of the 20 milligrams. Okay, so 6 milligrams. Okay. So if he takes the 20 milligrams a day, 30% is going to be available in the bloodstream. After 24 hours, half of it's going to be filtered out. So half of the previous day's concentration plus 6. Okay, so we have this function for the statin, right? So however much he had the previous day, half of that's going to persist, plus the additional 6 that he takes for that day. So let's think about this. So if we think about, let X be day 1, right? So the previous day was 0 because he didn't take any. So at the end, the maximum concentration in the day would be 6 milligrams for day 1. Let's kind of write this out before we go forward. So we're going to let A be the day, X be the days, and Y be the amount available. Right? So for instance, on day 1, the maximum concentration that he should have available should be 6 milligrams, right? Because he hasn't had time to filter any out. Then on day 2, it says that it's half of the previous day plus 6. So it's basically going to be 3 plus 6, so he should have 9 milligrams available. If we did day 3, this seems like it's behaving linear. I'm going to do one more. Half of 9. What is that? 4.5 plus 6 is 10, right? 10.5. So the maximum concentration he should have on day 3 should be 10.5. I don't know. Let me see. Is this linear? We added 3. It's not linear. What kind of function is this? Okay, I think we have a function though. Half of the previous day's concentration plus 6. Let me think about it. Let's kind of keep going. I think we're okay. We were getting the same results. So that's more like a log function actually, but we're definitely not talking about logs just yet. Okay, but I mean, we were on our way, right? So I think day 1, the most he had was 6. Day 2 was 9. I think day 3, we got to 10.5. If we just kept going, right? So by day 4, half of the previous plus 6. So that's going to be 5.25, 11.25. Let's see, how do we do? So on and so on, right? So half the previous plus 6. And so we can see the 10 days and we plot the order pairs. This actually, I mean, it's like exponential decay. Is this logarithmic? Log will approach there. Yeah, this looks exponential to me. It's like a exponential decay. But we haven't gotten to modeling this with exponents, so that, we shouldn't have to do this with exponents. Now I'm tempted to model this with exponents to see if it behaves exponentially. I totally want to do this. All right, I'm going to see if I can do it quick. You don't have to do this just yet. I'm just going to see if I can do it. So let me see. If I wanted to make a model for this, when I see this data displayed like this, to me it looks exponential, right? So I'm going to model it to an exponential function. We got, let's do a naught e to the kt. So let me think about it. Oh, that's going to be a bit much, because I'm going to have to do a little bit of work. We'll get to this and we'll be able to do it. I don't want to eat up time right now crunching through this, and I don't want to confuse you guys. But we're going to come to this eventually. We should. This is going to be my first time through this set of notes, but we've definitely talked about this before, so we'll see. We'll see if we get to that before the semester's out. Okay. But that's a little preview of what's to come. That was exponential decay, and we can model it, right? Okay. So I think this was the last slide for this set of notes. Okay. Let me first. Let me see. What's the time? Okay. Let me see if I can take attendance. Let me actually just hide this one. Let me see if I can pull up the attendance. I'll share these notes towards the end of class because it's something else that I want to do. Let's go back to here. Let's actually close that out. Let's go here. Come on, Blackboard. Now you know you want to work. Courses. Now it looks like it's working. This is the actual lab, so we're going to go here. Okay, look, it's moving and grooving now. attendance. Okay, let me stop the stream so I'm not streaming all of our personal information.